Problem number 16 is a typical example of motion on an inclined plane. A skier is going down a slope with a 15-degree incline, and the question asks for the change in velocity after 10 seconds. The problem description mentions ignoring friction and air resistance. These are concepts related to force, which we will learn in the next chapter. For now, let's assume those conditions don't exist and just focus on the motion of the object itself. As explained earlier, let's first determine the coordinate system and the origin to analyze the motion. In most cases, we use a coordinate system consisting of an axis parallel to the slope and an axis perpendicular to it. As shown in the figure on the right, we use an orthogonal coordinate system tilted along the slope, and generally set the initial position of the object as the origin. Now, we can solve the rest of the questions as one-dimensional acceleration where the object moves down along the slope. One tip for actual problem solving is that, unlike when we analyze motion using a standard Cartesian coordinate system, we don't worry too much about the positive or negative signs when calculating velocity or acceleration here. In other words, in our previous analysis of 2D motion, we assumed the right and upward directions were positive, and calculated velocity or acceleration moving left or down as negative values. However, in inclined plane problems, the coordinate system is tilted, so the object isn't moving exactly right, left, up, or down. Therefore, when solving actual problems, it's more convenient to understand the direction of motion through the diagram and just use positive values for the magnitudes during calculations. Now, let's get back to the skier going down the slope. The magnitude of the acceleration in the parallel direction is calculated as gravitational acceleration pointing straight down times sine 15 degrees, which equals 2.54 meters per second squared. Therefore, using the velocity formula, the final velocity after 10 seconds becomes 25.4 meters per second. As we did when solving the problem just now, please keep in mind that we did not use negative values to account for the direction of gravitational acceleration or the object's motion. Instead, notice that we simply use the magnitude of gravitational acceleration to calculate the magnitudeo of the acceleration component parallel to the inclined plane. To put it simply, because the coordinate system is tilted on an incline, it's easier to just look at the diagram and calculate the magnitude itself. Even if you analyze the same problem as the skier going down toward the right, you get the same result. As shown in the figure below, when going down to the right, you can think of an orthogonal coordinate system tilted to the right according to the direction of motion. If you calculate only the magnitude of the component of gravitational acceleration parallel to the slope, you can multiply by sine 15 degrees using the left-right triangle as seen in the figure. Or, you can calculate it by multiplying gravitational acceleration by cosine 75 degrees using the right side right triangle. The important thing to understand here is that it is much simpler to understand the direction through the diagram and just calculate the magnitude of the velocity,